In this chapter, we're also going to learn this thing called logarithm. Logarithm is, we write it short as logs. So we will always say logs. So what does logarithm mean? Well, it's actually really very much related to the exponential functions we have been learning. So it looks like this. Now, when you write it, you can see that there are several different levels to this. You can see that there is this subscript b that is slightly lower than the log. The log and that a are the same height. So if you don't write it this way, you're going to get yourself very confused. Is this an exponent or what is it? So please be careful with the way you write them. Now, what does all this mean? Well, this b here, this is the base. Just like the base in the exponential. And just to remind you, or not to remind you, to let you know, I forgot to let you guys know the other day, b has to be positive. So for exponential graph and for log graph, b has to be positive. Okay, b has to be positive. The way you say this whole thing is you say log base b. So you say log base b. A comes next, so you say of a. Log base b of a equals x. Log base b of a equals x. So this is the way you say that. Now we're going to figure out how to switch between logarithm to what we learned on Tuesday with exponential. So for example, this one. This is the exponential that we learned on Tuesday. We're going to switch that into a logarithm form. So what we're going to do is we're going to start from the base. So the base of the exponential. The base of the exponential is the same as the base of the logarithm. So we're going to start from here, and then we're going to do a loop rule. Since we start with the base, we're going to write that as the base. So remember, base is a little bit lower than the log. It's like the subscript, so lower. Okay, and then we're going to take that base, and then we're going to loop around. So when we loop around, we first reach a. That a comes next, so a is going to be here. A is the same height as log. Okay, don't write it as an exponent. It's not an exponent of b. Okay, next we loop around back to x. So we're going to write equals x. Okay, so this is the loop rule. We start at the base, go around to a, so a comes next, and then back to x, so equals x. Okay, so we're going to practice before we go on. 3 to the 4th is 81. Is 3 to the 4th 81? Yeah. Yes. Okay, so we're going to change this into logarithm form. So we are going to take the base, which is 3. So that's going to be log base 3. Loop around to 81. So 81 comes next. Back to the exponent, so equals 4. Good? Easy? All right. Now we're going to look at another example. This one's a little different. What's different from this one and the first one? It's flipped. So then you want to flip it back in order to write this into the log form using loop rule. So what is the base in this case? 10. Good. So log base 10. Loop around 100. Loop back 2. All right, let's have you guys practice 3 and 4. Let's start with Matt again. Number 3, what is your answer?
Log 6.
Ooh, log, how do you say it? Log, not 6.
Base 6.
Good.
36.
Oh, log base 6.
Of 36. Equals 2.
Good. All right, G1, number 4.
Log base 3
Uh-huh.
of x is equal to 2.
Yes, good. now we're going to switch between from log form into exponential form. So same idea. We're going to always start at the base. So start at the base, loop around. When we loop around, that number is now the exponent. Okay, so take the base, go around again. The first thing you reach is the exponent, goes back. That's on the other side of the equal sign. So start at the base, loop around. The first thing you see is the exponent, and it comes back, and that's the other side of the equal sign. Okay, let us practice. So we're going to go to the bottom of the page. Okay, so let's look at this one. What is the base on this question?
2.
Good. So we're going to start at 2, loop around, and that next 2 becomes the what? Exponent, and then loop back equals 4. Good. I think you guys can practice the other 3. Go ahead and figure out the exponential form. All right, let's start with Jeff. Number 2.
5 to the 4th equals 625.
Good. Isaiah, number 3.
3 to the 3rd equals x.
Okay, and what does that number equal to? You're like, I didn't expect this.
27.
Okay, 27. So eventually we're actually going to evaluate the x values. Number 4, Aiden.
4 to the 3rd equals 64.
Good. All right, next. Oh no, my log has no base. So when you see no base in the log, it actually means 10. So because it's so common to have a base 10, they decided to just leave it out because they don't want to write 10 every single time. And therefore, we call this the common log. Common log means log base 10. So log base 10, we usually write it with no base because it's so common that we don't want to write this 10 every single time. Common log. So whenever someone says common log, they mean base 10. So we're going to practice again, switching between the exponential form to the log form and the log form back into the exponential form, but with base 10. Okay, so go ahead and try it. All right, let's start with Brooklyn. Number 1. Oh, okay. Oh no. So there's a
No, wait. I did 2. I didn't do 1.
oh, you didn't do 1? Okay, then tell me what you get for 2.
Log to the base 10 of 1000 equals 3.
Good. What's another way of writing this?
Log 1000.
Yes, log 1000 equals 3. So we don't need the base 10 because that's a common log. Lauren, do you have number 1?
Is it 10 to the 1st equals 10?
Yeah. Okay, so what does this all mean? Well, it is really just asking the question, base b raised to what exponent x will yield a? So that's what log is really asking. Base b to what number is going to give me a? That's what log is. So we're actually going to figure out that x value. So for example, log base 3 of 81 equals x. Log base 3 of 81 equals x. So in order to figure out what x is equal to, what we can do is do our loop rule. So start at 3, loop around, and then back to 81. So that is 3 to the x equals 81. So the question is 3 to the what is going to give you 81? 4. So x is equal to 4. Eventually, you're not going to see that x next to it. You're just going to see this. And you need to know that the answer is just 4. Because in your mind, you're saying 3 to the what is 81. Okay. Next one. So what question is this asking for?
What to the eighth is 32?
No.
8 to the what is
8 to the what is 32. So 8 to the what is 32? 3? Too big. 8 times 4 is 32, but 8 to the 4th is a very big number. Because 8 squared is already 64, right? So it's, yeah, so it's a fraction of something. So the question is, how do we solve? Well, let's think about it. Huh? Calculator. Well, there's a faster way than the calculator. So if we can somehow turn 8 and 32 to have the same base, what does 8 and 32 have in common with a base? Like something to a something power. 2. So 2 to the what power is 8? So this is 8 is the same thing as 2 cubed. So it's just 2 to the 3x because I just leave that x there. What about 32?
2 to the 5th.
Yeah, 2 to the 5th. So if this side and that side are the same, the bases are the same, then the exponent must equal. Right? This is the only logical solution, saying left-hand side, right-hand side are the same, bases are the same, the exponent must equal. So 3x must equal 5. So x is 5/3. Okay? All right, number 3, I want you to try this with your partner. Figure out what this is equal to. All right, let's talk about our answers. Does anyone have an answer you want to share? Well, it's -3. What do you say? No solution. No solution? No solution. The answer is no solution. How? Okay, so this is equal to x, right? 3 to the x is -27. 3 to the x is -27. So the question is 3 times itself by how many times will give you -27? Well, it's impossible. If you keep multiplying a positive number, you're never going to get negative. So that means it is no solution. In fact, it is impossible to have a negative number in there because there is no way you're ever going to get a negative number by multiplying a positive number by itself. So every time you see a negative there, it is always no solution. All right, we are ready to practice. So 1, 2, 3, 4, 5, 6. Sorry, this one should be 3. 1, 2, 3, 4, 5, 6. Go ahead and try all 6 and let me know when you're done. All right, let's start with Josiah. Number 1. 4. Nick, number 2. Kendrick, number 3.
3/2.
Yes. Lynn, number 4. Huh? Okay. Ellen, number 5.
No solution.
And then Jackson, number 6. Yeah. All right. Next, we're going to do some log rules, and this has to do with the cheat sheet that you got. And so whatever notes you copy on here, you can also copy on here. That way you don't have to keep looking at your notes, just in case you forget. All right, so these are some log properties. So for example, number 1, if you see a log plus another log, and the important thing is they have the same base. If they have the same base and you're adding 2 logs together, then adding actually means multiply. So you can combine them into 1 log with the same base and multiply the 2 numbers inside. You're not multiplying 2 logs, you're multiplying the 2 numbers that's inside. Okay? So sometimes people forget they just multiply. They're not multiply the inside. Same thing with minus. If you see a minus, you can combine 2 logs into 1 log by dividing. So you can just divide the 2 numbers inside. First one divide by the second one. Okay. All right. Let's look at an example. So let's go down to number 1. Log base 4 of 32 minus log base 4 of 2. What can we do to combine the two logs together? Divide. So log base 4 of, okay, so 32 divided by 2, which is 16. So log base 4 of 16. We can further simplify this. This is actually what number? 2. Because this is asking the question, 4 to the what is 16? So 2. Okay, let's try another one. This one, number 2. What can we do to combine the two logs together? Multiply. So log base 2 of 15. Can I simplify this? No, that's it. All right, let's have you try number 3. All right, Matt, what'd you get?
I got log 4.
Oh, log 4?
Or log base 4
Uh-huh.
of 15x squared.
Yes, good. All right, we're going to not do number 4 for now. Let's go through all the other rules. Number 3, if you see a coefficient in front of a log, you can change it so that it becomes the exponent of everything inside. Everything inside. If there's only one number, then that number gets the exponent. If there is a polynomial inside, the whole polynomial gets the exponent. So this becomes log base b of m to the k. All right, notice how many levels there are now. It's going to get pretty crazy. You have the base b, which is on the subscript. You have the k, which is the exponent. So there are 3 levels right now. You got to write it clearly, or else you're going to forget which one belongs where. All right, so that's rule 3. Rule number 4, log base b of 1. Remember, this is really asking the question, b to the what is 1? So b to the what is 1? So what is it? 0. So the only way you can get 1 is if the exponent is 0. So x is 0. In fact, any log of 1 is always 0. So you're just going to remember log 1 is 0, no matter what base. Okay? Thank you. All right, log base b of b. Remember, this is again asking the question, equals what? So b to the what is b? Good. So this is always 1, which I'll show you a shortcut later. Next one, log base b of b to the k. So again, this is where you have 3 levels, write it clearly. This is equal x. So b to the what is b to the k? Yes, x is k. So now I'm going to show you the shortcut. The shortcut is if you have a log base b and the exponent has the same base b, they actually all cancel. So base b, they cancel. You only have a k left over, so k is the answer. Okay, so this is shortcut. If you have a log that has the same base as the exponential base, then they just all cancel. The exponent is the answer. Okay, so let's look at the previous rule. This is the same thing. This b is the same thing as saying b to the first. So then log base b, the exponential base b is the same base. They cancel, so you get a 1. Okay, so this is the shortcut. All right, last one. This is the crazy one. You see how many levels there are? You have a b as the exponential. You have a log, and then you have a little subscript, and then you have a k. And if there's another exponent on top of k, then it gets really crazy. So please write carefully. Base b, they cancel. So it's just k. You can try to prove it to yourself with log rules, but loop rule, but it really, all you have to remember.
Wait, is the b in the far left the k from earlier? Like above rule 3, where like k is next to log?
Why is it below?
Is b like that, or is it something different?
No, so this is saying this is the exponential This is b to the some power.
Oh, so it's
And
b
that
to the
power is log base b of k.
Oh, shoot.
Right? It's a b to a power. That power is a log.
So when you do the loop rule, like if they're different,
Huh?
if like the b in this is different than the base, when you do the loop rule. does that happen as
Okay, so, okay, you can do a loop rule. So you can just say b to the x is log base b of k. It's so crazy. You,
Yeah, that's gonna
You
confuse
have
me.
two X's.
oh, I'm sorry, I did this wrong. I did this wrong. Change it to log, right?
Second
Log base b of x is equal to log base b of k. I'm changing from an exponential to a log. This is very confusing. I think this is more confusing than just remember the shortcut.
Yeah. That's
So
how you got
the K in the one you had earlier with the loop is K for the
This K here?
the K like in your loop.
Yeah.
Okay.
If the base has an extra.
Is that K
Yeah, like
log or
like
for
b.
B?
For log.
Give us that.
Yeah.
So I feel like different
Then it
numbers,
would cancel.
Okay.
when they don't cancel, then
It probably won't say that.
like if it doesn't cancel,
the
then
bases
how do you
have to be-
do?
Would we ever have a problem where it doesn't cancel?
Okay, so if it's 7 to the log base 8,
Well,
if
the
they
base
don't
is
cancel
the
out,
same.
if they're not the same,
If
then
base is
what
the
do
same,
you
the
do?
base-
if the base is not the same, you can't cancel.
B.
Then what do you
They're
do?
both B.
That's wrong.
You're trying to figure out K? So I'm assuming there's a number here then, right? I mean, they have to, you can only have one variable if you're trying to solve for that thing. If you have too many, then you can't. You can try the loop rule. Okay, let's see what happens if you do loop rule. I've never seen this problem. Okay, log base 7 of 12 is equal to log base 8 of k. You can solve. It's going to be a little crazy. We will figure out how to solve it at the end of the chapter. Yeah. At the end of the chapter, you know everything you can to solve logs. Like this is, Algebra 2 is the basis for all your math later. So by the end of this year, you learn all the rules of math, and then you can apply to anything you want. So by the end of this chapter, you'll figure out how to solve this, if you want. No, not necessary. Okay, so number 4. We're going to combine it into one log. Now, to combine this into one log, there are a few rules. First, we know that there's a minus in between. The two bases are the same. We know we're going to divide. However, we cannot divide as is. If there is an x coefficient, you have to change it as the exponent first. Basically, you have to change it so that there's just a log and a log without a number in front. If there's a number in front, you can't combine. Okay, so this is very important. Some people just start combining and they don't know what to do with that number in front. You have to change it. So log base 2 of x to the 6th minus log base 2 of y to the 5th. And then you can combine them. Okay, so what does this become? Log base 2 x. Yes, good. All right, let's come back to rule number 1. Now we learn how to combine logs into one log. We're going to expand it. So from one log into many logs. Oh, I see. Okay, yes. Okay, number 1. So if you have a log base b of something times something, we expand it. It becomes 2 logs. How do we combine those 2 logs? By adding or subtracting? Adding. Okay. Log base b of m plus log base b of n. So we're going to add them together. The second one. Log base b of m divided by n. How do we split them?
Subtract.
Okay. Isaiah is way too into this analogy. Okay. Minus. The last one, if you have an exponent, what do you do with that exponent? Bring it to the front. So k log base b of m. All right, let's practice. Huh?
I said
Kellogg.
Yes, yes. All right, let's do one together, and then you're gonna do the rest on your own. Sorry. On the bottom. Okay, number 1. Log 4x over y. Yes, it is log 10. Log base 10. So there are a few things going on. We have a 4x divided by y. So maybe we can think of it as 4x divided by y first. So dividing means what? Subtract. So we can think of it as log 4x minus log y. However, that is not the most expanded version. 4x. What can we do to 4x? 4x is the same thing as what times what?
2 squared by log x.
Yeah, log 4 plus log x, because 4x is the same as 4 times x. So when we split it, it's log 4 plus log x, right? 4 times x. Times means adding. Minus log y.
Plus log x minus.
But that's not it. We can do some more with that 4.
4, because 2 times
2
2.
times 2 times 2. So 4 is the same thing as 2 times 2. So you can either do 2 times 2 and then split it, or you can think of it as 2 squared and then bring the 2 to the front. Yes? 2 log 2 plus log x minus log y. Okay, this is as expanded as you should go. Don't go any more than this, then it gets a little bit too much.
You can go more?
Is it not?
I mean, some people write it as log 2 plus log 2,
Yeah.
you know, but that's just overboard. Any question on this? Are you ready to try it on your own, or you need one more example? One more example. All right, let's try number 3. This one right below. What can we do to expand this? Yeah?
Well, what? Answer.
You add.
Okay, yes, you add. You eventually will cancel something, but let's do adding first. So what adds to what?
Log base 7.
49.
49.
Plus log 7.
Oh, not 7. Base 7. Okay, and then you were going to say?
And then you do the square root.
Square root.
Or like you move the 2 to the front, right?
Where is the 2? You're too far ahead of us.
Because it becomes 7 times 7.
7 times 7.
Yeah. So 7 squared.
7 squared.
Yeah. And then
You move the 2 to the front. But wait, there is more.
yeah.
Where does the 2?
But wait, there's more. What else can we do?
Quit math.
Huh?
The base in jump is the same.
Base is the same, so cancel, so you get. Okay, yeah. So that thing cancels because it's just 1.
So is it
Wow.
14?
So no, it's 2. Log base 7 of 7 is 1,
Oh, you only cancel
right?
that.
There is a little exponent of 1. The base and base, remember, base and base, if they're the same, they cancel. 2 plus log base 7 of x.
Is that it?
Yes, that is it. You can't do any more. Are you guys okay? You guys seem a little confused. Huh?
Is the x an exponent or is it at the...
It's not an exponent, it's a regular.
It was like when she was first trying to teach us I.
Oh,
Oh,
yeah.
yeah.
All right, 2 and 4. Let me know when you're done.
Here. I was like,
All right. Oops. Oh. Okay. Number 1, 1. Number 2, 3. Okay, because that's an invisible base. Number 4. A lot of you had a very confused thing going on. Log base 3 of 3, that cancels. The 2 becomes a real number. So it's just 4 times 2. That's 8. Number 4 is 2. Number 5, this is a little base here, so it's just 3. You can also use your loop rule. Okay, that's another way to do this. This is 3. This is 2. And this is 9. All right. That's it for today, and we'll do change of base tomorrow.